Okay, we're gonna actually jump into chapter 2. Chapter 1, you are responsible for, but frankly, not very much of anything. So the only thing you have to worry about really from chapter 1 is the scientific method, and that's about it, basically. So there's not really much in chapter 1. So I'm not going to waste the time. I'm probably not even going to ask a question on scientific method, but you should just read that little part about scientific method, which is actually on these notes, by the way, just in front of us and stuff. Uh, so make sure you take a look at that. And other than that, we're just going to try and jump into the heart of the class, which really starts with chapter 2. Uh, like I said, not much going on in chapter 1. So chapter 2 is about measurements, and we're going to talk about in this chapter how to take proper measurements. We're talk about significant figures. We're going to talk about dimensional analysis, conversions, which is the way they want you to show your work in this class and beyond. And we'll finish up talking about density. So measurements is really important. Measurements is really all about units as well. So for example, units is really important because if I just say something like, hey, I have 100, you know, really what does that mean? You don't really know what that means. That's just a number. I could have $100, which would be great. I could have 100 pennies, which would still be good, I guess, right? I suppose. I could have 100 pizzas, which not bad. I could probably make some money off 100 pizzas and sell them or something. So a number by itself is pretty much useless because it doesn't give anybody any frame of reference as to what it means, right? So when I say, I have 100 pennies, for example, now I have a frame of reference of what that number means. So whenever you take a measurement, you should always have a number and it should always have units. They're very big on that here in this class and classes as you continue on. So you should never have really any kind of numbers by themselves. You need that unit to tell people basically what scale you're talking about. So in terms of units, there's really kind of two types of units. There is the English unit is sometimes referred to, or the US unit is sometimes referred to. And then there's pretty much what everybody else uses, which is the metric system. So everybody uses the metric system. We use, again, sometimes referred to as the US or English system. And you could imagine that, everybody using sort of different units does create sort of a situation, especially as people are sort of doing business with each other in different countries. If somebody's doing some type of metric measurement and somebody's doing some type of English measurement, that's a real problem. And that's actually how a lot of accidents have happened with, things like space shuttles and stuff like that. Everybody's using different sort of measurements or airlines and stuff like that. So in 1960, they actually had a conference on weights and measures, and they sort of came together with a international system of units, and that is what is sometimes referred to as the SI system of units, which is the International System of Units. Frankly speaking, it's pretty much the metric system kind of one out there. So it's really based off the metric system. It's very similar to the metric system. And that is what we use a lot in chemistry. So sometimes in chemistry and sciences, you'll hear like the SI unit for this is that, or the SI unit for this particular type of measurement is something else. So these are the common sort of SI units and the different things that they represent. We have mass, and kilogram is a very common unit. We'll talk about some other units in a bit. Length, the meter, is a very common sort of unit. Time is seconds. And temperature is something that maybe you're not familiar with, but in chemistry you'll become very familiar with. Temperature, we use Kelvin, and Kelvin is the standard unit for what we use for temperature. Pretty much, if it is a chemistry sort of formula, and you have temperature, it usually needs to be put into Kelvin before it goes into like any type of formula. I would say we'll only come across in this class one formula where it is not in Kelvin. Pretty much that's almost like a no-brainer. Like if you got temperature, you got to put it into some type of formula. You should just convert it to Kelvin. Obviously, we'll talk about how to do that a little bit later on in this chapter. So it's also really important when we talk about measurements that we understand what it means. So for example, when we talk about mass, some common units of mass, length, and so forth are different than, the units that we would see for volume versus length versus mass. So when I say I have a mass of 5 milliliters, that is incorrect because a milliliter is actually a unit of volume, right? Or if you say you have a volume of 20 grams, that's incorrect as well because grams are mass units. So it's really important. And sometimes students have a hard time connecting the dots in terms of what that unit represents in terms of, is it a mass, is it a volume, is it length? So it's really important not only to know these units, but to understand really what type of measurement you are talking about. So if we look at some length measurements, meter is a very common unit. Other very common units you come across in terms of meters is centimeters. You see a lot, kilometers, and millimeters as well, by the way. Millimeters is also another very common unit that you come across. 1 centimeter is 0.01 meters. That's also 100 centimeters is equal to 1 meter. So that is also a conversion. By the way, you get that by dividing both of these guys by 0.01. And that's how you get to that guy. 1 kilometer is 1,000 meters. So I would say definitely that's one you should know. I would say that's a good one to know as well. These are basically these guys written in scientific notation, which is a number between 1 and 10 times 10 to the certain power. So I would say in most chemistry classes, especially this one and others, meters, kilometers, centimeters, millimeters are definitely length measurements that you should know. So like I said, definitely it's a good one to know for sure. So make sure you know those guys. Now, because of the metric system, we actually will use prefixes a lot. And we'll use prefixes to sort of change the meaning of the numbers. So this table is a good one. Again, you should have this one in your book as well. We have mega, kilo, deci, centi, milli, micro, and nano. I would say, truthfully, in most of your chemistry classes, you're going to probably hit one of those prefixes at some point. I would say probably oddly, the one that we don't see too much in chemistry is deci. We don't see deci all that much, but you should still know it. And this is one of those things that you should know. Now, there's a couple different types of meanings that you see there for each of these prefixes. Now, there's sort of the larger value, and there's really the scientific notation type value here, which is very commonly how you see these prefixes sort of written in tables. And like I said, you will need to know these prefixes, so make sure maybe put a star on this one. You'll definitely need to know these ones, or probably the major ones that you'll need to know for this class for sure. But people always screw up using these things. So what do I mean by that? Let's just take one, for example, and pull one out here. So let's just say we had the kilo, which is, if we go here to our power of 3, 10, 10 to the 3. What is 10 to the 3? 10 to the 3 is really written in scientific notation as 1 times 10 to the 3. And that really is 1,000, by the way. So let's just say we had grams and kilograms. And we were looking up on the table, or we memorized that kilo is 10 to the 3. How do they relate to each other? How they relate to each other is in one of the base units, that is how many there are. I'm sorry, in one of the prefix units, that is how many there are in the base unit. So what are we talking about? The base unit in each of these are grams. That's like your base unit, right? This is our prefix unit. That is kilograms. So what this means is 1 kilogram, there are 10 to the 3 grams, or 1 times 10 to the 3. And it's very common. People always flip those guys around and use them sort of backwards. Does it matter what the base unit is? The answer is it does not. If I had meters and kilometers, and one of my prefix units, I would have 10 to the 3 meters. So that is the proper way to use that. Again, people always sort of do it backward. By the way, in this case, you could use the larger number. 1,000 grams is a kilogram, or 1,000 meters is a kilometer. Now, if we had something, say, like our centi here, which is 10 to the minus 2. And that, by the way, is really 1 times 10 to the minus 2, which is in real sort of decimal form, 0.01 is basically what that number represents. So what does that mean? If I have grams and centigrams, again, grams is our base unit on each of those. And in one of the prefix units, which is 1 centigram, there would be 10 to the minus 2 grams is basically what that means. And again, it doesn't matter the unit. You could do liters and centiliters. Centiliters is the prefix unit, so 1 always goes with the prefix unit, and it would be 10 to the minus 2 liters. So again, that's a super common error that people make, which is they kind of always want to go the opposite way. Like there's minus 2 centigrams in a gram or something like that. So make sure that you understand how to use these correctly. We definitely will, like I said before, see pretty much all these prefixes here. Like I said, deci, probably not too much of that, but the rest of them are very, very common. Probably not too much in this particular class, micro and nano, but you might, but you'll definitely see micro and nano if you go off to 1A and stuff like that. They use that a good amount of times as well in some of the questions. Any questions on prefixes or how to use them? No. Yeah.
That whichever unit should be the 2, that's the base unit.
That's exactly what that is. Yeah.
But the other deviation is.
Yeah, so the way I remember it is it's basically one of the prefix units. So whichever one has the prefix in it will be a 1. And then when you're using the 10 to the power, basically when you're using this last column here, version of it, that's what goes with the base unit by itself, no prefix. So it's basically in one of those prefixes, that's how much there is in the base unit. Yeah. Other questions? Yeah.
On like the 10, the exponent.
Yeah.
How many zeros are either added on both sides of the
Yeah, we're actually going to talk about scientific notation in this chapter as well, which is what that really is. But basically, scientific notation, kind of use this page here. So for example, scientific notation has basically this setup, n times 10 to the n, and that is a number between 1 and 10. And not 1, not 10 or above, but basically between 1 and 10. And this is either a positive or a negative number, depending on which way you need to move the decimal place. So to get to a number between 1 and 10. So when you have something like 10 to the minus 2, that really is 1 times 10 to the minus 2, which basically means in this case you have 1. The minus means you're actually going to make it a smaller number, so we would assume the decimals here, and the 2 means we're going to go 1 and 2 places basically to do that, and that would get us here 0.01 in this case as to how we convert that into sort of a regular number, as opposed to the 10 to the 3, which represents 1 times 10 to the 3. Positive exponents, when you're kind of going back into regular number version, makes it a larger number. So again, you start with the 1 and you assume the decimal is there, and we're going to go 1, 2, 3, and then you will add your zeros there basically, and you'll get your 1,000, and the decimal point would end up technically at the end, but you wouldn't actually write it. But that's how you do that. So when you have something written in scientific notation with a negative exponent, it basically represents a smaller number. The decimal place goes to the left, and then you put zeros in however many places you got to move it, and that will get you your number out of scientific notation. And if you have it in scientific notation, you have a positive exponent. the decimal place goes to the right and you add in the zeros that you need to do so. Other questions on that? Okay. So here's a difference between sort of English and metric system. Inches are English system. Metric is on the bottom, and that's a conversion that they definitely want you to know for sure. And that is 1 inch is equal to 2.54 centimeters. That you definitely need to know. And you can see there, that is a ruler, by the way. Up on top is inches. On the bottom is centimeters. Yeah, so that is centimeters. That is inches. By the way, the little guys here are what? Little guys on the bottom are? They're millimeters, yeah. So there's 10 millimeters in a centimeter, right? So those little guys on the bottom are millimeters when you look at it. That is definitely a conversion they want you to know. That's what's known as an exact conversion. So 1 inch is exactly 2.54 centimeters. So that's what's sometimes referred to as an exact conversion. Talk a little bit about volume. Volume is the amount of three-dimensional space that is occupied by a substance. Excuse me. Volume is meters cubed. So here's some conversions that are useful. 1 decimeter cubed is equal to 1 liter. 1 centimeters cubed is equal to 1 milliliter. So that is a conversion that you need to know. That is 1 cubic centimeter equals 1 milliliter, basically. Now, how do we get something like that? We get that by if we take like a cube, like the length times the width times the height, and you measure with a ruler like a little cube, and you measure each of them in centimeters. Each of these individual measurements, these are all length measurements, yeah? So each of the individual, like if you took a cube and you measured it with a ruler, the length times the width times the height, those are all length measurements. If you multiply all those measurements together, in the case of a cube, that will actually equal a volume, and you will get a cubic centimeter, which is actually a volume. So that's how we get cubic centimeters. That's how we get cubic decimeters, meters cubed. If you take a length measurement, basically and cube it, you will get a volume. So that is a volume, which again is different than the individual measurements that are centimeters, which are length measurements along the way. This is also one for sure you need to know, those two. 1 liter is 1,000 milliliters. So 1 cubic centimeter equals 1 milliliter. By the way, sometimes a cubic centimeter is abbreviated with a cc. Like if you ever watch any type of medical show where they say, give that guy 5 cc's of this before he dies. Yes, that is basically 5 milliliters. It's what they use a lot of medicine. Cc's is a cubic centimeters, and that is a volume. So when we look at a volume, those are definitely, we don't see cc's too much in this class. We see more cubic centimeters written like that, but they are a one-to-one relationship. So if you had to convert between a cubic centimeter and a milliliter, it's basically the same number. You just need to change the unit. And 1 liter is 1,000 milliliters is a very common conversion. By the way, that is the same milli conversion that we see in that table. And if you look at milli in that table, it will be 0.001 or probably 10 to the minus 3. And that is basically what you get if you divide both sides by 1,000. You will get that one of the prefix units equals 10 to the minus 3 of the base unit, basically, in that case. Any questions on that there? All right, we'll lay that up for lecture.